let's get started with the permutation and combination of S1, the topical review. In permutation and combination, let's get few things straightened out. The first thing is, if we talk about properties of NCR and NPR. Now we should know that NCR, the C stands for selection. Order does not make a difference. When we talk about permutation, P for permutation, this means arrangement. Naturally, order does make a difference. Does make a difference. And over here, in order to arrange something, first select, then arrange. Now, this is known as permutation. Now, if we talk about the properties of NCR, NC0 is 1. Similarly, NCN is 1. When we talk about the property of NPR, NP0, because if you're not selecting any one, what's the point of arranging it? That's also 1. But NPN, that is n factorial. You're selecting everything, you have to arrange everything. Now, first of all, take out your calculator and let's go one by one on it. If I write 3C0, just double check. If I write 3C0, that is 1. If I write 3C3, that is 1. The best example is to explain the idea that there are 3 people, A, B, C. I want to select none of them. That's only one possibility. I want to select all 3 of them. That's also one possibility. But now if I talk about NPR, I want to select 1 and arrange it. It's also 1. Just double check. 3P0 is also 1. But if I select all 3 of them and I want to arrange them in a line, so the answer will come out to be 3 factorial, which comes out to be 6. Got the idea? N factorial, A, B, C. In this case, N is 3. ABC, ACB, BAC, BCA, CAB, CBA. This is order does make a difference. That is the basic idea. Now let's also do one thing. Some property, another property of NCR. NCR is the same thing as NCN minus R. For example, the same 3 people, ABC. If I select one of them, if I form a group of 1 person, automatically a group of 2 of them is formed. So if I write this thing as 3C1, which comes out to be 3, the answer is the same thing as 3C2. If I separate out 2, the answer is also 3. So over here, this 1 and this 2, it adds up to this 3. NCR is NCN minus R. For example, 5C2, the value is 10. What else will be 10? 5C3. Similarly, if I talk about a 6C2, that is 6 into 5 and 2 into 1, that is 15. 6C2 is 15. That is the same thing as 6C4. So it makes life easier for the calculation. And naturally, there was also a question. I think it was in the paper in which it was about astronauts and some other thing. So a question like this was asked. If I come across, I'll just let you know. So this is another important property. And one other property that relates NCR and NPR, that is NCR into R factorial is NPR. It means first select, then arrange. That is the same thing as arrangement, permutation. In order to arrange something, you need to first select it. For example, if I evaluate 5c2, which is 10. If I write 2 factorial, which is 2, 10 into 2 is 20. That should be the answer of 5p2. Double check. So 5p2 should be 20. So I took 5c2. I multiplied by 2 factorial. That is 10 into 2. Therefore, these two multiplied together will give me what? 5p2. That's another important thing. Now, when we talk about combination, NCR, we deal with questions that is related with selection of a team. So it could be about a team. It could be about a delegation. It could be about a committee. These are the sort of words that you come across. It could also be something like that, that forming a group. Let's say 9 people are there. You want to divide them into groups of 2, 3, and 4. So that will fall under this category also. When we talk about NPR, we are talking about some digits and number formation, even number, odd number, greater than something, lesser than something. So these are the kind of question, because in number formation, order does make a difference. It could be about letters and their arrangement. And it could be, and then in those questions, it's about together and not together, and then separated. The terminology that they use, it's not next to each other. So let me go over some questions which are already solved. I'll walk through them so that we can conserve time. So first of all, I can start with the old papers first, and then we'll go to the new ones. So if I go to S1 and permutation combination, and this one, the first one, let's get started with this. So now permutation, lecture 1, order makes a difference. This is the basic idea of factorial. You have studied this. And then NPR, N stands for number of available letters or digits or books or anything. And R stands for number that needs to be arranged. So 2p2 is 2. That's the same thing as 2 factorial. 3p3 is 3 factorial. So therefore, we get this idea that NPN is n factorial. We are starting just going over the basics. The same idea, first select, then arrange. That's the same thing as permutation. If we deal with identical objects, if there are 2 alphabets and if they are identical, what is the point of arranging them? So they can be arranged in one way. That's common sense. I'll go to the formula in a short while. 3 alphabets, all 3 identical, one way. 3 alphabets of which 2 are identical, that can be arranged in 2 ways, because this is AAB, ABA, and BAA. But what is the background formula? The numerator corresponds to the number of letters, and the denominator corresponds to number of identical, to nullify the effect. So 2 factorial over 2 factorial for the 2a's is one way. 3 factorial over 3 factorial for the b's is one way. But over here, 3 factorial divided by 2 factorial, because there are 2a's which are identical. Now let's proceed. Something like this, apple, 5 factorial divided by 2 p's, that's 2 factorial. Statistics, STATISTICS, STATISTICS. So you separate it out. 3 identical letter S, 3 identical alphabet or letter T, 2 identical I's. This is without restriction. Then the concept of together, that is the box concept. Put it in a box, consider it one unit, add it to others. Take care of the outside, take care of the inside. Outside, inside. Not together, subtraction. MEX, mutually exclusive. Without any restriction, minus together will give us not together. The letters S and T are separated, not next to each other. Space concept. So we have H, I, O, R, Y, and there is an extra space. So whenever, for example, 5 alphabets are there, so there will be 6 spaces. The S and T could occupy any one of these 6 possible spaces. So 6P2 is for the spacing. 5 factorial, because these alphabets are not fixed. They also have the desire to arrange themselves, to move around. So that is 5 factorial. The letters S, T, and O are separated, the same concept. If we are talking about 2 objects, not together and separated is the same thing. If we are talking about more than 2 objects, whether it's alphabets or digits or books, not together and separated are not the same. Separated, all 3 separated, not together. If we are talking about 3, 2 can be together. That is 3 not together. AB together, C separate. BC together, A separate. AC together, B separate. That's the idea. Line arrangement, the same concept. 3 girls are together in a box, and then not together, that is subtraction. Separated, that is the space concept. Now, these boys and girls are not identical. So that's why we are not dividing. It will specifically say either it's identical, or if it's so obvious, if we are talking about alphabets, naturally that's identical. If we are talking about digits, that's identical. If they say identical pencil, that will be identical. Identical cans of cola, that will be identical. Unless and if something is not obvious, they will specify. Number formation, there could be questions of 2 types. Repetition not allowed, repetition is allowed. That means each digit can be only used once. That is another way of saying repetition not allowed. And over here, repetition is allowed. Each digit can be used more than once. NPR is such as not applicable. Factorial is not applicable. You have to write it out. For example, this is done side by side. This is like a revision exercise. So now over here, if we have 7 alphabets, 1, 2, 3, 4, 5, 6, 7, and we are forming 4-digit numbers. I think I forgot to mention it. We are forming 4-digit numbers over here. If there is no restriction and repetition is allowed, sorry, repetition is not allowed. This left-hand side is repetition is not allowed. Right-hand side, repetition of digits is allowed. Each digit can be used more than once. So basically, any one of the 7, any one of the 6, any one of the 5, any one of the 4, 7P4 means exactly the same thing. So this answer is there. Let me do all the without not allowed first. 4-digit even number. The last digit should be even. So out of those 7, how many digits are even? So we see that the 2, 4, 6, 3 digits are even. So now there are 2 ways about it. Either it's the concept of probability or it's the concept of writing it out. So if 2 digits are, if we are talking about even numbers, so there are 3 digits which are even. Any one of the 3 could occupy the space. 6 are left. Any one of the remaining 6 will occupy the space. Now I'm doing 2 things at once. Not only am I using the NPR button, I'm also showing it in the table. So even if I don't write this and write a 3 over here, that is perfectly fine. 6, 5, 4, 3. 3 for the even number. 3P1 is 3. And this is 654 for 6P3. 4-digit number greater than 4,000. Now focus on the first digit. The first digit could be any one of these 4. 4P1 or 4. Yes, you cannot write 4 factorial. 4 factorial is for 4 letter, 4 spaces. 4P1 you can write. You can simply write a 4. By mistake, even if you write 4C1, that will be marked as correct. Why? Because 4C1, 4P1 is the same thing. So the examiner will not judge your intention, what your intention was. I mean, even if you write NC1 or NP1, it means the same thing. But deliberately, we should not mix up the C's and the P's together. 654 for the rest. 4-digit number lesser than 3000. Lesser than 3000 will not include 3. It will include 1 and 2, 2p1, and then 6p3. 4-digit odd number greater than 4000. Now two conditions are there. What two conditions are there? The first one is odd. The second one is greater than 4000. 4-digit, of course, that itself is a condition. Now fix the first digit and write one line, one box for each digit. Greater than 4000, it could start with 4, start with 5, start with 6, start with 7. So separate boxes for each. Starting with 4, one possibility. Starting with 5, 1. Starting with 6, 1. Starting with 7, 1. This 1 is basically 1p1. Now focus on the last digit. So first, last. Since 4 is an even number, it will not affect the ending odd numbers. The odd 4 will remain as 4. So this is 4. 4p1 is 4. The same goes with 6. 1 over here, 4 over here. But if we start with 5, 5 is an odd number. There were 4 options. Repetition is not allowed. One number is less. So how many are left? 3. So 3 people. The same is the story with 7. A 5 remains any one of the two. 5 remains any one of the two. That goes like this. Either this or this or this or this. Add it all up. Now let's go back. The same question. This time repetition of digits is allowed. Each digit can be used more than once. So now over here, if repetition is allowed, we officially cannot use NPR because NPR has by default without repetition. That is why 7p4 is 7654. Why is it reducing? Because repetition is not allowed. So that is why we cannot use NPR. Now over here, if repetition is allowed, any one of the 7, 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 all of them can be used. That is 7 multiplying by itself 4 times. It's not 7 into 4. Indices, it's 7 raised to power of 4. Any one of the 7, any one of the 7, any one of the 7, any one of the 7. Over here, 4-digit even number, repetition of digits is allowed. Yes, there are 3 evens. So 3p1 for this. And then we have what? We have any one of the 7, any one of the 7, any one of the 7. Repetition of digit is allowed. 4-digit number greater than 4000. First digit could be 4, 5, 6, 7. This 4 is 4p1. Again, any one of the 7. Any one of the 7, any one of the 7. 4-digit number lesser than 3000. It could be 1 and 2. So 2 options, any one of the 7, any one of the 7, any one of the 7. And this was done in 4 steps. This is done in only 1 step. 4-digit odd number greater than 4000. First digit could be any one of these 4. Repetition is allowed. So 1, 3, 5, 7 for the odd. 7 was used over here. 5 was used over here. So what? Repetition is allowed. And 7 and 7 over here. So this is 4 square into 7 square. So that is the basic idea of this. Let me open another PDF. So now this is about basic type of questions. No, I don't need this one. That is too basic. And then I have the 3-1. I think that is permutation. Number formation we've done. I think let me pick this one. Now this is from your topical book. Permutation combination, first 10 topical questions, O1 till O10. That's in your Google Classroom. Now it says a committee of 5 is to be chosen from 6 men, 4 women. In how many ways can this be done if there must be 3 men and 2 women on the committee? So that is pretty basic. Select the men out of men, select the women out of women. So 6C3 into 4C2, 6C3 into 4C2. Second part, there must be more men than women on the committee. I think this working that's showing over here, that is, I think, of the third part. It says second, but it's the third part. This is the second part. So let me just correct myself. This is the second part over here. And over here, this one is labeled not correctly. This is the third part. Let's focus on the third part first. Now it says, if there must be 3 men and 2 women, and one particular woman refuses to be on the committee with one particular man. So let me do it in 2 ways. The first method, first of all, what I did is that I wrote 3, 2, 3, 2, 3, 2 all along, because that is the objective, 3 men, 2 women. If a particular man is selected, that means this 3 should be slashed off and written as 2, because one man is already selected. First, focus on just slashing. Woman is not selected, this 2 will remain as 2. On the other hand, on the flip side, if the man is not selected, this 3 remains as it is. If this woman is selected, the 2 is slashed and written as 1. Because we are not going into the basics of writing 1C1, which is 1, 1C0, which is 1. So what's the point of writing it? Just slash and work your way out. Both are not selected. If they cannot stand each other, then both should not be on the committee. So still we need 3 and 2. Okay. So now over here, 5C2, 3C2, that's this answer. 5C3, 3C1, that's this answer. 5C3, 3C2, that is this answer. So now when we add it up, that is 90. That's one approach. The other approach is select, form a committee with that person, that man and woman. So instead of 3, I need a 2. Instead of 2, I need a 1, because 1 is selected. So 5C2 into 3C1, that comes out to be 30 without any restriction. The answer of first part is 120. So 120 minus 30 comes out to be 90. So this was a question of combination in which that thing was there, in which one person cannot stand another person. The second part was straightforward. Now, the lesson to be learned over here is it's not necessary that part 1 and part 2 are related. Part 1 and part 3 are related. Part 2 was just a filler. There must be more men than women on the committee. So I'm writing all the options. It could be 0 men, 5 women, 0, 1, 2, 3, 4, 5, 5, 4, 3, 2, 1, 0, because the total has to be 5. And then you can select the one in which there is more men than women on the committee. That's the last 3. Evaluate and then add it up. Something like this. The word Argentina includes 4 consonants, R, G, and T. Now, what is the lesson to be learned over here? When you read 4 consonant, that means he is not denying the fact that one of the consonant might be repeated. Because first of all, now this was the old question. This is 2004 when this syllabus recently got started. Before 2001, A-level maths, there was no further maths. A-level maths was further maths. This was add maths. So they did not write how many words there are in Argentina. Now, when you see the recent questions, maybe after 2-3 years of 2004, they started writing it because people had a problem with counting also. So they would think if that's 4 and that's 3. How many is that? Total is 7. It's not 7, it's 9. Why? Because in Argentina, maybe one of these is being repeated and one of these vowels may be repeated. So this is A, R, G, E, N, T, I, N, and A. So basically it's 2 A's and E and I. And it's 2 N's and T and G and R. So now 5 consonants, 4 vowels. Okay. Yes, 2 N's are there. Yes, 2 A's are there. Find the number of different arrangements using all these 9 letters. Over here they have written 9. So now this is 9 factorial divided by 2 factorial for the A's, 2 factorial for the N's. Whenever you have a question like this, first separate it out, first break it out so that you have a clarity exactly what you're working for. How many of these arrangements have a consonant at the beginning, then a vowel, and so on alternately? Now the rule is, if they're talking with respect to consonant and vowel, they're talking with respect to boys and girls. They might be talking with respect to seniors, juniors, and they're asking about alternate arrangement. Only two options are there. Either the numbers are equal, let's say 3 boys, 3 girls, or there is a difference of only 1. Otherwise, it cannot be alternate. There is a difference of only 1. So it's necessary that you have to start with what is more. So since consonant is more, consonant, vowel, consonant, vowel, consonant, vowel, consonant, vowel, consonant. If you have started with vowel, so vowel, consonant, vowel, consonant, vowel, consonant, vowel, consonant, consonant. 1, 2, 3, 4, and this is 1, 2, 3, 4, 5. So this won't be alternate. So now 5 factorial for the consonant, 4 factorial for the vowels, 2 factorial for the A's, 2 factorial for the 9. That is the answer. Something like over here, bit of probability and some assumption. It says a staff car park has 13 parking spaces in a row. There are 9 cars to be parked. How many different arrangements are there for the 9 cars, leaving 4 empty spaces? Now, this is for later on. The identical thing is for later on. The first part is basic, 13P9. That's the answer. How many different arrangements are there if the 4 empty spaces are next to each other? Over here, you have to make an assumption yourself that the empty parking spaces, they are identical. That's how a parking lot is designed. So this is 9. The 4 empty spaces are together. 9 plus 1 is 10 factorial. Nothing is happening over here. Why? Because they're identical. If you want to write it, that's 4 factorial for the 4 spaces, 4 factorial for the identical. So basically, this is what. Then it says, part 3, if the parking is random, find the probability there will not be 4 empty spaces next to each other. Now, the first thing is they're asking probability. A lot of time people forget that they have to divide also. They have to write down the possibility. So the number of possible outcomes is 13P9. That goes down in the denominator. The answer of part 2 was what? 10 factorial, 4 parking space, empty spaces are together. So not together will be answer of part 1 minus answer of part 2. That is the numerator. This is the denominator. Maybe someday they can ask for percentage. So just multiply by 100. Something like this. Find the number of ways in which 12 letters of the word refrigerator can be arranged if there is no restriction. So now they have written 12 in the beginning in 2007. So REFRIGAGERATOR. So there are 4 R's, 2 E's, and then Figato. Now it says no restriction. That's basic. If all the R's must be together, that is the box concept. 1, 2, 3, 4, 5, 6, 7, 8. 8 plus 1 is 9. That is 9 factorial. And 4 factorial for the R's. First, take care of the numerator as if you have no knowledge of what's going to happen in the denominator. So if you have not studied the concept of identical, there won't be any denominator. So just focus on the numerator. These 8 plus the box, that is 9. Inside the box, 4 factorial. Because of identical, 2 factorial for the 2 E's and 4 factorial for the 4 R's. So as such, nothing is happening inside the box. I prefer writing it down and then doing the cancellation. How many different selections? Now selections of 4 letters from the 12 letters of the word refrigerator contains no R's and 2 E's. So separate it out. Now, this is the most important concept that usually comes, and this is the easy version. There were more difficult ones also. There was some in which we had to write it down. So 4 R's are separate, 2 E's are separate, and then Figato. So it says no R's and 2 E's. So no R's. So you are not taking any R's. You are taking both the E's. This is something different. Just ignore this for right now. Basically, the working is up till here. So that was some extra stuff that I did. So out of 4 R's, you're selecting none. Just throw them out. Out of 2 E's, you selected both of them. And you are selecting 4 altogether. That means the remaining contains no R's and 2 E's. I think this is not written correctly. I think this is the this thing over here is the correct. So now over here, I think I'm mixing up the two. So I think this one was 2. These both are selected. You have to select 2 out of 6. So therefore, this is 6C2. That is the answer. This was something else, that if this is not identical or identical, use one, dump the rest. Why can't we do this? The reasoning is, it's like photocopy paper. The same identical 4 R's are there. So for example, if you are selecting one of them, they all are identical R's, you throw away the rest. If you select both of them, you just select it and then you subtract it over here, but you don't use the NCR button for identical objects. That's another thing that you learn. Something like this. This one was a slightly different question. The 6 digits 4, 5, 6, 7, 7, 7 can be arranged to give many different 6-digit numbers. How many different 6-digit numbers can be made? Now over here, neither did they mention that repetition is allowed or not allowed, because digit itself is there. So this is just like A, B, C, D, 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 something like this. Now it says how many different 6-digit numbers can be made? 6 factorial divided by 3 factorial for the 7s. The next one. How many of these 6-digit numbers start with an odd and ends with an odd? How many odds are there? There is 5 and then there are 3 7s. It can start with a 5, end with a 7. If it start with a 5, 1 5 is used. If it start with a 7, 1 7 is used. 2 7s are left. So that is why division by 2 factorial. Why 4 factorial? Because 4 digits are there. Start with a 7, end with a 5, the same thing as above. This one starts with a 7, ends with a 7. 2 7s are used up because you have pasted them on the wall. 1 7 is left along with 4, 5, 6. So only 4 factorial over here, either this or this or this, and then you get this answer. Something like this thing. A choir consists of 13 sopranos, 12 altos, 6 tenors, 7 basses, whatever they are. A group consisting of 10, 9, 4, 4 is to be chosen. And how many different ways can the group be chosen? You select 10 out of 13, then 9 out of 12, then 4 out of 6, then 4 out of 7. So that is the basic idea. That is straightforward, 2 marks. In how many ways can the 10 sopranos be chosen, be arranged in a line? So now it's permutation. If the 6 tallest stand next to each other, now it's not talking about altos and tenors and basses. It's only talking about sopranos. So now out of 10, 6 tallest stand next to each other. 1, 2, 3, 4, 5, 6. They go in a box. 4 not so tall are on the outside. 4 plus 1 is 5 factorial. 6 factorial over here. Why am I not dividing by 6 factorial? Why am I not dividing by 6 factorial? Because it's not alphabet. This T is for tall. T is not for identical alphabets. Yes, they can be different. So that is why we are not dividing it. Got it? Now, the third part. The 4 tenors and 4 basses in the group stand in a single line with all tenors next to each other, all basses next to each other. So now we are only talking about 4 tenors, 4 basses. How many possible arrangements are there if 3 of the tenors refuse to stand next to any of the bosses? That means out of 4, one tenor does not have any issue. So he could be the middle person. So he could be over here. And from my perspective, these are on the left and these are on the right. Or they can be on the left, they can be on the right. So this person is like fixed, the dividing line. 3 factorial into 4 factorial or 4 factorial into 3 factorial. Of course, you can write it once and multiply it by 2 also. So let's move on. Let me see which questions are these, if there is any good one over here. Yes. Now it says, find the number of different ways that the set of 10 different mugs can be shared between Lucy and Monica if each receives an odd number of mugs. So now, out of 10 mugs, this is the possibility 1937557391. Now, out of 10, if I have used red color for Lucy and black for Monica. So 10C1 into the 9 goes over here. So we know that 9C9 is 1. So even if I don't write it, because it's multiplication, it doesn't make a difference. So 10C1 or 10C3 or 10C5 or 10C7 or 10C9. So add it all up. The next one. Another set consists of 6 plastic mugs, each of a different design. Yes, the material is plastic, but the design is different, so it's not identical. Another set consists of 6 plastic, different design, 3 china, different design. Find in how many ways 9 mugs can be arranged in a row if the china mugs are all separated from each other. So 6 plastic, 1, 2, 3, 4, 5, 6, 7 spaces. In these 7 spaces, these 3 could fit in, that's 7p3. And these plastic mugs can also arrange themselves 7 factorial. It's not identical, there is no denominator. 6 factorial. The next one. Another set consists of 3 identical red mugs, 4 identical blue mugs, 7 identical yellow mugs. These 14 mugs are placed in a row. Find how many different arrangements of the colors are possible if the red mugs are kept together. So now these 3 red are together. 4 plus 7, 11. 11 plus 1 is 12. That is the numerator. For these 3 factorial. And then 4 factorial for the blues, 7 factorial for the yellows, 3 factorial for the reds. Now this one, 3 identical cans of cola, 2 identical cans of green tea, 2 identical cans of OJ are arranged in a row. Calculate the number of arrangements F. The first and the last in the row are of the same type of drink. So it could be cola, the purple cola, the green tea, and the orange. So any one of these, now this is identical. Just put any cola up front, just paste it on the wall, just paste it over here. We won't write 2C1, we won't write 3C1, nothing like that. How many are left? Altogether, how many are there? 3 and 2 and 2, 7. So 1 is used up, 5 is left. So 5 is the numerator in all of them, 5 factorial. 2 factorial for the green tea, 2 factorial for the OJ. Over here, the 2 green teas are used. 3 factorial for the colas, 2 factorial for orange juice. Over here, orange juice is used. 3 factorial for the cola, 2 factorial for the green tea. Spend more time in writing, less time in calculation. First, write it comfortably so that your calculation can be correct. Now it says the 3 cans of cola are all next to each other. And the 2 cans of green tea are not next to each other. So the 3 cans of cola in a box. And the green tea, it's separated. That's why you don't see it over here. This is the OJ, orange juice. So 1, 2, 3. Spaces 1, 2, 3, 4. First of all, 4p2, that is for the space for green tea. 3 factorial, that is for 1 unit, 2 unit, 3 unit. This 3 factorial is for the colas on the inside. And then divide by 3 factorial for the cola, divide by 3 factorial for the 2 factorial for the OJ, and 2 factorial for green tea. Now I'll pause the recording over here, and I'll select these 2 questions and I will ask you to try it. Now let's look at the solution to this particular question. The question is right over here. It says a committee of 6 people, which must contain at least 4 men, and at least 1 woman is to be chosen. Now, the very first thing is, if I take exactly 4 and exactly 1, so that adds up to 5. That means there is a gap of 1 unit. So either I can increase the number of men or I can increase the number of women. That means the committee could be 5 men, 1 woman, or 4 men, 2 women. That is the first thing that you need to decide. First part, find the number of possible committees that can be chosen. It's out of 10 men and 9 women. So the first part is this that I'm focusing on. 10, 9, 5, 1, 4, 2, 10C5 into 9C1 or 10C4 into 9C2. Evaluate both of them and add it up. The second part, find the probability that one particular man, Albert, and one particular woman, Tracy, are both on the committee. If they are both on the committee, out of 5-1, I just need 4-0 because they are already chosen. And out of 4-2, I now need 3-1 because they both are already chosen. So therefore, now also this 10 became 9 because Albert is over here. This 9 became 8 because Tracy is over here. Got it? So that is 9C4 into 8C0. This, if you want to write, that is 1C1 into 1C1. And this is 9C3 into 8C1 into 1C1 into 1C1. That comes out to be this. You add it up, you get the answer. That is the numerator. Answer of part 1 is the denominator. That is the number of all the committees that can be formed. The third part. Find the number of possible committees that include either Albert or Tracy, but not both. Now, this is the part that requires most attention, even though it's only worth 3 marks, but this one was the most difficult one. Now, just focus on this. First of all, this is 9, this is 8, this is 1, this is 1. If I talk about the 5-1 committee, because now there are 4 options. 2 options for 5-1 committee. Why? Because Albert could be there, Tracy not, Albert not, Tracy yes. The same goes for 4-2 committee for Albert and Tracy like this. Now, if Albert is chosen, out of 5, I just need 4. If Tracy is not chosen, this 1 remains as it is. If Albert is not chosen, 5 remains as 5. If Tracy is chosen, 1 becomes 0. Just focus on this. Do not focus on writing this out. That is the easy part. Similarly, if Albert is chosen, 4 becomes 3. Albert not chosen, 4 remains as 4. Tracy not chosen, 2 remains as 2. Tracy chosen, 2 becomes 1. And now just work it out. 9C4, 8C1, 9C5, 8C0, 9C3, 8C2, 9C4, 8C1. Just write down the 4 answers, add it up. That is the answer. And the last part, that was the committee is chosen from 4 men and 2 women. This is the easy part. They queue up randomly. Find the probability. Again, they're asking the probability that the women are not next to each other. That means they are separated. So men, 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 men. And in these 5 spaces, 2 women can fit in, 5p2. 4 factorial for the men. That becomes the numerator. Denominator is 6 factorial. All good? Okay. Let's move on. Now let's look at this question, because without any restriction, this is arrangement. It's asking for probability. So without any restriction, they're asking for probability. Last part, just have a look. I'll do it over here. This thing, it says the committee that is chosen consists of 4 men and 2 women. They queue up randomly in a line. So this is arrangement. This is not selection. Find the probability. Women are not next to each other in the queue. So there are 4 men, 1, 2, 3, 4. There are 5 spaces, and 2 women can fit in these 5 spaces. So this is 5p2. What about the 4 men? Multiplied by 4 factorial. Whatever this answer is, that becomes the numerator. If 6 people arrange in a line, that is 6 factorial. So that is the denominator. Because this is not combination, this is permutation. It's not, no. They queue up randomly in a line. This is arrangement. 4 men and 2 women. We are not forming a committee. These 6 people are now getting arranged in a line. So that is why. So combination, 3 parts of combination, 1 part of permutation. Now let's look at this question which I was talking about. Find the number of different ways in which 12 letters of the word strawberries can be arranged if there is no restriction. That's the first part. If the 4 vowels A, E, E, I must all be together. So 2 S, 3 R's, 2 E's, and so on. A, E, E, I all together. 1, 2, 3, 4, 5, 6, 7, 8. 8 plus 1 is 9. That is 9 factorial. Inside the box, 4 factorial. 2 factorial for the S, 3 factorial for the R's, 2 factorial for the E's. Now this B part 1. 4 astronauts are chosen from a certain number of candidates. If the order is not taken into account, what are they talking about? Combination. If the order is not taken into account, the number of ways or the astronauts can be chosen is 3876. This is some value of NCR. How many ways are there if the order of choosing is taken into account? What are they asking for? Permutation. For a particular value, they have given us NCR. They're asking for NPR. And how many astronauts are we talking about? 4. So now we have to use this rule. NPR is NCR into R factorial. So the value of NCR is given. We don't know what is N. 4 factorial is 24. Whatever the answer is, that's the value of NP4. They are not asking us N. They're asking the value of NP4 if the order of choosing selection is taken into account. It becomes permutation. Order of selection does not take into account. That is combination. Let me just check. I think that the recording is on. Okay, now this one. 4 astronauts are chosen to go on a mission. Each of these astronauts can take 3 personal positions with him. How many different ways can these 12 positions be arranged in a row if each astronaut's positions are kept together? Now we have 4 different astronauts. So astronaut A, B, C, D. Their personal position 1, 2, 3, 1, 2, 3, whatever that is. It should all be kept together. So A1, A2, A3 together, another box, another box. But it's not necessary that the lining of these boxes should be in this order. So 3 factorial for each one of them multiplied by 4 factorial for the boxes. So now let's move to some new questions from 2023. And our focus right now is on this thing. So this is the first paper. Okay. Now let's look at this. This is May, June 2023, variant 51. Find the number of ways in which a committee of 6 people can be chosen from 6 men and 8 women if it must include 3 men and 3 women. So it should include 3, 3. And 3, 3 is 6. So basically, we are choosing 6 people. Men out of men, women out of women. That is the answer. Exact, needs no rounding off. 1120. So a lot of people, they ask this question, that should be rounded off to 3 significant figures. The answer is no. If it's inexact, then you round it off. The next one, a different committee of 6 is to be chosen from 6 men and 8 women. 3 of the 6 men are brothers. Find the number of ways in which the committee can be chosen if there is no restriction of the numbers of men and women, but it must include no more than 2 of the brothers. So that means no more than 2. That means maximum of 2 brothers. So now I have done this question in 2 ways. The first one is just following the instruction. Maximum of 2, it could be 1, it could be 0. So 3 brothers are on the side, 3 men and 8 women on the other side. This adds up to 11. This is 3. So it could be 0, 6. It could be 1, 5. It could be 2, 4. Just write it down, add it up. That is the answer. What is the other way? Just like the question that we did in the beginning, that if a particular man and a particular woman are not supposed to be together, find the number of ways in which they are together and then subtract. The same over here. Maximum of 2 brothers are allowed. Altogether, there are 3 brothers. So what if I select all 3 brothers? So if I select all 3 brothers, that's 3C3. The remaining 3 should be out of these 11. That's 165. Without any restriction, 6 out of 14, that's 14C6. 14C6 minus this value, that gives us the exact same answer. So this was combination. Another question of permutation. Now find the number of different arrangements of 8 letters of the word cocooned. So 2 C's, 3 O's, and ED. 8 factorial, 2 factorial, 3 factorial. Find the number of different arrangements of the 8 letters in which the first is O and last is N. First is O, even though it's identical, that's why we just take 1 and paste it on the wall. We won't write 2C1. Ends with an N. How many N's are there? Only 1 N. So N goes over there. How many are left? 2 O's are left. 2 C's are left. ED is left. That is 6 factorial divided by 2 factorial, 2 factorial. Okay, now this one was something difficult that came in that paper. Find the probability, always do underline. So let me just underline over here. Let me choose a color marker. Find the probability that a randomly chosen arrangement of 8 letters in the word cocooned has all the 3 O's together, given that the 2 C's are next to each other. So now the word given is there. So it's like conditional probability. Now given, that is conditional probability. The 2 C's are next to each other. So 2 C's, 3, 3, 6, 6 plus 1, 7. That is 7 factorial. Inside the box, 2 factorial. Inside the box, 2 are identical. Divide by 2 factorial. For these 3, 3 factorial. This comes out to be 840. And then it says this thing. This thing is happening as well as the 3 O's are together. Got the idea? Given as a condition, that will happen as well as the 3 O's are together. So 2 C's, 3 O's, and ED, that's 5 factorial. What is happening in this box? Nothing. What is happening in this box? Nothing. So this comes out to be 120. So the probability is 120 over 840. You can further simplify it. 1 over 7. Probability A slash B. Probability of A occurring given B has already occurred. This is the official definition. Probability of A intersection B, the common thing. So this one was the common one. This one was the condition. That, what is that? The 2 C's are there. That is what comes after given is the condition. Condition goes down in the denominator. Something relevant out of the condition goes up. What is the relevant thing? That not only the 2 C's are together, the 3 O's are also together. So these were 2 questions of this particular paper. Let me go to the next paper. Okay, I think that's the mark scheme. The examiner report. Now it says, in general, they're talking about including everything. We started today with permutation combination. Candidates, let me just first clear this thing up and then I'll underline it myself. Candidates need to be aware that working and explanations are required to support the answers. That means, even though it's something very basic, that if there is division by 2 factorial for identical for 2a's, make a habit of writing 2a's. Make a habit of drawing boxes and so on. It is especially important to include all the required steps when proof of a given result is called for, including the mathematical operations. If you are showing division, if you are showing simplification, if you are writing factorial, of course, you will just write a factorial and then use a calculator. There is no harm in using a calculator, but show all the necessary steps. Good solutions were characterized by clear communication, particularly when combining different results or scenarios. That means the different steps. Like, for example, in this particular question, I showed clearly that that is given. Then the common thing, then the division, then the simplification. Where a diagram is required, it should be clear, accurate, and appropriately labeled. It could be a histogram, it could be CF curve, it could be box plot, it could be stem plot. A key should be given, a scale should be given, everything should be there. The axes should be labeled. Candidates should only state non-exact answers correct to 3SF. Non-exact. Exact answers should be stated exactly. That is obvious. To justify a final correct answer to 3SF, working values correct to at least 4SF should be used in these calculations. When they say at least, that means that value is included. So let's play it safe. We will work a level of accuracy more. We won't overdo ourselves. Then it says, there is no requirement for fractions to be converted to decimals. What does it mean? That means if the answer is coming in fractions, leave it in fractions. Why is someone bothering and using a calculator? Fractions are ultimate. Fractions are supreme. Fractions are exact. Leave it in fractions. There are questions of conditional probability in which you work in fraction and in which you work in decimals, and after simplification, even if the answer is coming in fraction, write it down. Decimals exact are good. Fractions are supreme. Decimals inexact, it's better to work in fractions. You will feel it from the question itself. General comments. Most candidates use the response space effectively. Where there is more than one attempt at a question, candidates, yes, this is important, more than one attempt at a question, candidates should ensure that they clearly identify which one they intend to present for marking. That means just cancel out the other thing. Candidates should ensure they clearly identify which one they intend for marking. That means cancel the other one out. So that is cancel the rough work. Clearly put a box, and let's say if this thing is cancelled, just cancel it out and say, just write rough work over there so that they know what exactly has happened. When extra space is required, candidates should use the additional page in the first instance. So there are 2 or 3 additional pages that are given. Just use it, just label properly. So make sure that you label properly. Label properly. Let me choose this one. The use of helpful diagrams, sketches, and tables were frequently seen in good solutions. Now read it backward. What are good solutions? That use diagrams and sketches and tables. Right? The examiner has categorized that the use of helpful diagrams and sketches and tables were frequently seen as good in good solution. So good solution should accompany all these things. They often supported and efficiently organize the explanations. Now this they means the diagrams and the sketches and the tables. In normal distribution, the way that I've taught it, I have explained it with a sketch, but I have taught the rules so well that as such, you don't need a sketch. So if you're doing it all correctly, that's perfectly fine. But if there is a need for something, maybe there is a need for something like those questions in which we do something like this, that we have a value over here, let's say 55, and the mean is over here mu, and some value over here 80, and maybe this thing is given, let me just label it, maybe this thing is given only, or maybe this whole thing is given only, something like that, and you need a particular space, so you draw a diagram. Or maybe you need this thing over here, so you just do the subtraction and this and that and something like that. So now it says many candidates were able to tackle the earlier parts and frequently the later parts seem challenging. That is all about it. Now let me talk about this question, the combination thing. Question 2 was combination. It says that many candidates were able to part A, but many found the restrictions in part B more difficult. Most candidates identified correctly that combinations were required to give the number of ways that the committee was chosen. The correct combination of men and women were frequently seen. Many successfully found the product. That means men from men and women from women. That is the product that they're talking about. And gave the right answer. A significant number of candidates found this sum. Yani they are talking about a mistake. Or maybe they are talking about that they got the two answers and they also added those two. Maybe someone has left it as it is. Then it says stronger candidates often give an indication that the number of brothers required was 0, 1, and 2. I am one of the stronger candidates because I told clearly that maximum of 2, so it could be 2, it could be 1, it could be 0. And found the number of ways of selecting the remaining candidates from 11 people in each case. So that was maybe 3 men and 8 women, something like that. This situation, which requires the multiplication of combination, so it requires the multiplications of combination and the addition of these scenarios, is quite common. A few have adopted the method, selected the remaining committee members from 8, some omitted one of the scenarios. So this is a mistake. Some omitted one of the scenarios, most often 0 brothers. When adding to get the required answer, a few successfully listed all the 12 scenarios. 12 scenarios of men and women of each number of brothers and found the associated combination. Why would anyone list 12 scenarios? I mean, the examiner is stating that someone listed everything out. Many of those who attempted this method did not get all the scenarios. Of course, if there are 12 scenarios, how will they get all the things correct? And would have been well advised to list the options in a logical manner. Some use the efficient method. That is method number 2 that I talked about. So some use this as method number 2. That is based upon the concept of mutually exclusive, that use the efficient method of subtracting the number of ways all 3 brothers could be selected from the total number of ways the committee could be selected. Most of these found the total number of ways of selecting the committee 14C6, but were unsure what to subtract for 3 brothers. So, I mean, even though they got it correct, maybe they were unsure about the subtraction. So we did it both ways. So that is one question that we did from this part. And then this next question. This question number 3. There were a lot of good solutions to part A and B, which demonstrated the understanding of arrangements with repeated O's and C's. That means they are talking about identical objects. Many candidates found part C least accessible and were unable to deal with the conditional probability. The first part, it says the number of arrangement of 8 letters with 3 are O's and 2 are C's is a fairly standard application involving factorial and was completely successfully by many. Some solutions indicated the candidates thought the O's and the C's were distinguishable and just gave 8 factorial. That means they forgot to consider that this is identical. Most candidates realized that they had only 6 letters to arrange. Stronger solutions were often accompanied by a simple diagram which showed the number of spaces to be filled and the letters that were left to fill them. So that is the box concept. Some omitted the denominator of 2 factorial into 2 factorial to deal with the repetition of remaining O's and C's. Then it says a significant number of candidates found this part more demanding, the conditional probability part. Good candidates realized that this was an application of conditional probability where there were 5 items to arrange once the O's and C's has been grouped together, and 7 items to be arranged, 3 of which were O's and where the 2 C's were next to each other. Basically what we did, we first found the condition, then we found the common thing, then we divided. Weaker solution simply found the number of arrangement with 3 O's together and 2 C's together and divided by result by 3360. That was answer of part A. No, it had nothing to do with part A as such. So this is the examiner's perspective regarding this particular thing. So now let's move on, and we are not doing probability as of now. We're focusing on permutation. Okay, now let me just add this page over here. And let me just add one thing over here. And let me send you these 2 pages so you can try it out. Then we will look at the solution. I'll just pause the recording. So now let's look at this question. The question is about, in a group of 25, there are 6 swimmers, 8 cyclists, 11 runners. 6, 8, 11. Each person competes in only one of these sports. A team of 7 is to be selected from these 25 to take part in a competition. For the number of find the number of different ways in which the team of 7 can be selected if it contains exactly 1 swimmer, at least 4 cyclists, at most 2 runners. So at least 4, at most 2. That means one possibility is what's written, 1, 4, 2. This 1 cannot be changed. You can play around with 4 and 2. At least 4 means 4 can become 5. So 2 can reduce to 1. 5 can become 6. 1 can reduce to 0. So there are 3 options. The 3 answers are written over here. This is the total answer. That is the answer in the exact form. Leave it as it is. Is this all good? Next one. For another competition, a team of 9 consists of 2 swimmers, 3 cyclists, and 4 runners. So that number is gone. These are new numbers. The team members stand in a line. So again, it's arrangement. How many different arrangements are there of the 9? If the swimmers stand together, the cyclists stand together, the runners stand together, just like the astronaut question. 2 factorial for this, 3 factorial for this, 4 factorial for this. It's not necessary that the swimmers come first, so the boxes can arrange themselves in 3 factorial ways. How many different arrangements are there of the 9 people if none of the cyclists stand next to each other? So again, this is separated. So 2 swimmers, R stands for what? Runners, I think. So 2 swimmers, 4 runners, 3 cyclists are separate. They can go in these 7 possible blank spaces. 7p3 for the cyclist, 6 factorial for these 6 people, 151200. Say that again. Sometimes life is not fair. So, I mean, I know it's a lot of mark for this. Maximum 3 mark would be enough. Maximum. Even they can get away with 2 marks, but this is too many marks. Okay, let's move on and let's look at this thing. Let's read the mark scheme for the examiner report for this one. This was question number 6. Acha ji, let's have a look. It says this permutation and combination question was found challenging. I don't think so it was challenging. Okay? But candidates who listed logically possible scenarios, that is what we write in the table, that is the logically possible scenarios, often achieve good solutions. Candidates should be aware that how the question is presented provides some additional guidance for the solution. as additional information was presented before part B, this is additional context for the remainder of the question and may require not only in part B, but also part C. Now, this is important. Let me go back over here and let me show you this thing that over here, this part A was for the team of 7. That was this one swimmer and cyclist and runners, right? And then this paragraph over here, that is not part of part B. That is before part B. So that means this part is for part B. This part is for part C, for both of them. That paragraph applies to both. That's what the examiner is letting us know, something very obvious. And then it says, candidates, part A, candidates who listed the 3 possible scenarios that fulfilled the criteria were frequently successful. Best solutions included the unsimplified calculations involving the combinations linked with each scenario. A misconception was that the number of swimmers was fixed at 1, which would have no effect on the way the teams could be selected. So 6C1 was omitted for each product. Let's see if we skipped it or not. Okay. No, we wrote 6C1. We fixed the number, but of course it has to be taken out of 6. So 6C1 is there. We took care of everything. Let me go back over here. And then it says that the weaker solution sum the combinations to find the outcome for each scenario. That means instead of multiplication, they simply added it up. So that was wrong. Part B, candidates who used a simple diagram to clarify the requirement given in the question were often able to identify not only the team could be arranged within their groups, but that the groups themselves could be arranged in different orders. So, I mean, those boxes. Let me just draw a box over here. So boxes were necessary. Now it says common errors were either not to arrange the groups with an answer of 288 or not to arrange the people within the group. So these are errors. A number of candidates assumed that they needed to select the identified people that they needed to select. That means they were thinking that this is combination and not permutation. So increase the complexity of the question. As an additional information was given before the question was started, this is an indication that the previous condition would no longer be applied. The number of swimmers and all these things changed. Many candidates found the spot challenging. We found it the easiest. And the question was not attempted by a surprising number. That's why it's for 4 marks. 2 main approaches were used to answer the question. The most successful was to consider how the people who were not cyclists were arranged and then how the cyclists could be placed. Good solutions often use a simple diagram. Simple diagram, I believe in that. A common less successful method included deducting the number of arrangements. No, we won't do the deduction because we don't have to worry about identical and everything. We are fixed on the concept that if they are talking about together, that is the box concept. If they talk about not together, that is the mutually exclusive, the subtraction concept. If they talk about separated, not next to each other, that is the space concept. So we will just do it this way. So that is the working for this one. Let me give you one other question from here, or let me just explain it. This is probability, binomial, probability DRV. This is stem plot. This is stem plot, box plot, normal distribution. Okay, let's look at this question. It says, find the number of different arrangements of the 10 letters of the word Casablanca. 2 C's, 4 A's, SBLN, in which the 2 C's are not together. So even if it's 2 objects not together, I can do it separately. So this is 1, 2, 3, 4 A's, SBLN, that's 8. Yes, we draw a diagram, but we should be aware that the number of spaces will be 9. So out of 9, fit in these 2. Both are identical. Divide by 2 factorial. For these 8 factorial, 4 factorial in the denominator for 4A's. Then it says, find the number of different arrangements of 10 letters which have an A at the beginning. So just take one A and paste it. and A at the end, another A, paste it. And exactly 3 letters between two C's. So you have to write it out. So there are how many? 2 C's, 4 A's, SBLN. And there are exactly 3 letters between the two C's. So technically, out of 10, we are not talking about these two. We are talking about 8 of them. And let's start with the first thing. That is C, 3 spaces, a C, and then other letters. So if I move this one over here, this one will move here. That's the second option. Then the third option, this one will move over here. Then the fourth option, this one will move over here. And then there are A's guarding at the front and the end. So there are 4 lines. So 4 possible rows. This 4 is for these 4 rows. This one is for the front. This one is for the end. And then we have 6 factorial. That is, these C's are also fixed, because you're just fixing the arrangement of the C's in each line. So the C's are also fixed. So you are left with 1, 2, 3, 4, 5, 6, out of which there are 2 identical A's. Is this thing clear? Listen to it once again. A at the front, A at the end, C, and then 3 spaces, and then C, and then the remaining spaces. This C is also 1. This is also 1. This is also 1. This is also 1. So 6 are left. So this 6 is for that. Since 2 A's are used, 2 A's are left. That's 2 factorial is for that one. This 1 and 1, and for C 1 and 1. So no use of writing it. This 4 is for 4 line. The second position of C, and then there are 3 spaces left. Another position of C, then there are 2 spaces left. Another position of C, 1 space is left. Another position of C, then no spaces left. So there are 4 lines like that. So 4 into 720 over 2, that comes out to be 1440. Another question. 5 letters are selected from the 10 letters selected. From 10 letters in the word Casablanca, find the number of different selections in which the 5 letters include at least 2 A's, at most 1 C. Perfect question. At least 2 means either 2 or 3 or 4. At most 1 C, that means either 1 or 0. So now you have to find a perfect balance between the two. So first of all, just focus on this. Just focus on the A's and the C's. So let's say at least 2 means exactly 2 is possible. At most 1 means 0 is there. So basically, if I fix this 2, it could be 2, 0. It could be 2, 1. Basically, I'm playing with 0, 1. So 3, 0, 3, 1. 4, 0, 4, 1. That's it. Now change this number accordingly. Since we have selected 2, I want remaining 3 because I need a total of 5 out of these 4. So this is 4C3. 2 plus 1 is 3. Select 2 out of 4. This is 3. Select 2 out of 4. This is 4. Select 1 out of 4. This is 4. Select 1 out of 4. This is 4 plus 1 is 5. Select 0. Still you have to write it. Now this is different if it's about a probability. I have done a video which has that dollar notation in the thumbnail, something like that. That was maybe a past paper question of like a year before or 2 years before. That was a classic question in which when we talk about identical and the question is about probability, so 3 will be taken as 3. The whole background is given over there. Do watch that video. I'll share the link. So just watch that video. I mean, this is about number of ways. So this is done this way. Let me see. I think if there was one question, I don't remember the exact year. That was in this one also. So let me do one other question. This is probability. This is also a nice question. This is November 3rd variant of 2023. Now it says in a restaurant, the tables are rectangular. Each table has seats 4 people, 1, 2, 3, 4, 1, 2, 3, 4. 2 along each of the longer side of the table. There is no one sitting over here. There is no one sitting over here. 8 friends have booked 2 tables, X and Y. R, S, and T are three of these friends. Part A, the 8 friends will be divided into 2 groups, division of groups, combination. One for table X, one for table Y. Find the number of ways in which this can be done if R and S must sit at the same table as each other and T must sit on the other table. Now, first focus about X. 2 out of 2, these 2 should be there. The remaining 5, 2 more out of 5. Now, how many people are there? 8. So let's say R and S sit over here. This is not arrangement, this is selection. The remaining 2 seats should be filled out of 5. So that is what is over here. And then one particular person, tan, T, should be at table Y. The remaining 3 should, of course, be belonging there. The same over here, it's just basically change of order. This 2C2 into 5C2 goes over here. This 1C1 into 3C3 goes over here. So whatever is the rule for table X, that's the same rule for table Y. Let me repeat it again. R and S over here. 6 are left, but I'm choosing from 5. Why? Because I'm separating T out. So 5C2 over here. Then that person T over here, 3C3 over here. The same thing multiplied by 2. So that comes out to be 20. The next one. When the friends arrive at the restaurant, R and S now decide to sit at table X on the same side as each other. T decides that he does not mind at which table he sits. Find the number of different arrangements. That was combination, grouping. This is arrangement for the 8 friends. Now, fixed RS at every possible position. RS could be here. RS could be here. SR could be here, SR could be here. Like I'm changing the order, I'm changing the sides. Top side, RS, bottom side, RS, top side, SR, bottom side, SR. That is the thing. So there are 6 factorial positions because if I'm focusing their position, I have already made 4 diagrams. So I'm writing 6 factorial for each one of them, 4 into 6 factorial. So it doesn't make a difference where T sits, where the others sit. So it's all about RNS. Next one. As they leave the restaurant, again, this time look at the diagram. So that's what the examiner is talking about. That simple diagrams to aid your working is a necessity. As they leave the table, the 8 friends stand in a line for a photo. Find the number of different arrangements if R and S stand next to each other, but neither is at the end of the line. If you look at it closely, this is just like what we just did. A at the front, A at the end, and then there were 3 letters between C, not exactly the same, but something like that. So no one could be A at the front, A at the end. So this front, this is the end. I have labeled like terms of arithmetic progression or geometric, T1, T2, T3, all the way till T8. And this is R and S. I think I have chosen the color somewhere. Yeah. So R is blue, S is green. So this is R is blue over here. R is blue, S is green. So this is RS. And they are together. So one possibility, other possibility, third possibility, fourth possibility, fifth possibility. This one could not be there. These 5 possibilities are for what? R first and then S. So we can have another 5 possibilities. S first, R at the end. So basically this is 5 rows into 2 are the swiping thing. And this 6 factorial for the rest of them. So therefore, this comes out to be 10 into 720, that is 7200. So I think I'll just stop over here. So that is S1, the permutation and combination. We are all done with this first thing.